Okay, so let's go ahead and get started on lesson 12. Today is our first of 2 consecutive lessons on word problems, applications. All of these applications are going to lead to a system of 2 equations, and then we'll use our new techniques of either substitution or elimination to solve the systems. So the only new thing is going to be setting up the systems, and then the old technique that you just practiced here, you'll use to finish these problems. Just fair warning, the first day of word problems is easier than the second day. So coming up on Thursday, the word problems are just going to be tougher. Okay, daily summary. In this lesson, we look at applications of systems of linear equations. These applications involve total value and investment problems. Those are the 2 kinds of problems we're going to tackle today. Next class will be different kinds of problems. Number 1, 2 types of candy sell for $2.50 per pound and $4 per pound. A store clerk is trying to make a mixture worth $11.70 with twice as much cheap candy as expensive candy. How much of each type of candy should be included in the mixture? Let's follow the steps below to find out. So let's make sure we all understand the goal here. We've got twice as much of one as the other, 2 different kinds of candy. We're going to mix them together, and we want it to be worth a total of $11.70. So we got variables defined. That's already done for us here, but in the activity today, you will have to think about what your variables should represent. In this case, it says how much of each type. Those are our variables. We'll let C equal the number of pounds of the cheaper candy, and E be the number of pounds of the more expensive candy. Again, make sure you include units, number of pounds, quantity word, unit word. Okay, we're going to use tables in order to help us organize the word problems today. Now, I will never force you to use a table on the test. In fact, I won't even give you a blank table. So if you find that the tables are useful to you as you work through the problems today, then make sure that you're prepared to bring the table in when you take the test. And you could put like a sample table on your reference sheet if you want to. Now, your table is already filled in, but I want us to really see what it looks like when it's empty. So you're welcome to put your pencil down or like make a blank table elsewhere and then follow along as we fill this stuff in. Okay, first thing, cost per item is the easiest part. How much does the cheaper candy cost per pound? $2.50. How much does the more expensive stuff cost? $4. Sometimes we'll fill in information in the total row. In this case, it doesn't make sense to add 250 and 4 to get, like nothing costs $6.50 a pound, right? So we'll just leave that blank. Okay, number of items. In this case, it's number of pounds. And the number of pounds of cheaper candy was just one of our variables. What is it? C. So we put a C there. And the number of pounds of expensive candy we denoted with an E. And sometimes the problem will tell you how much candy you have altogether. It might say 10 pounds, in which case we would put a 10 in the total. But we don't have that information here either, so that's a blank. And now we get to the total value. We'll just play a quick little game. Suppose that you have 4 pounds of the cheaper candy. How much would that be worth? One vote for $10. How do we get $10? Multiply by the cost. So we would take the 4 pounds times the 250, yeah? But we don't know that we have 4 pounds. We have a variable. We have C pounds. So in this total value, instead of 4 times 250, it's going to be C times 250, or maybe 250 C. So that's the total value of that candy. Likewise, what's the total value of the expensive candy? 4 times E. We buy it. And it is going to be quite typical for us when we make our tables to multiply the first 2 columns to get the last column. And the problems will change in context. We'll see problems that have nothing to do with candy, but it's still going to be set up in such a way that multiplying the first 2 columns gives you the last column. But I don't want you to just memorize it. In this case, I hope it makes sense as to why that's true. Okay, the total, again, I just want numbers down here. The total value of all the candy is in the problem. What is it? That's 1170, okay? So we set up the table for the sole purpose of trying to write equations. Again, table's not mandatory, but just go with me with the table for a little bit and you might find it helpful. So in the right-hand column, we're just going to get an equation. We have $2.50, we have 2.5C is the value from the cheap stuff. We have 4E is the value from the expensive stuff, and altogether it's supposed to be 1170. So the equation we're going to get is just 250C plus 4E equals Should be 1170. Can you guys fix the typo that I made there? That 1760 was a holdover from another version of this problem, and I missed it when I changed the problem. Okay, and then the other equation is going to come from the one piece of info we haven't used yet. It says twice as much cheap candy as expensive candy. We just have to read it a few times. Twice as much cheap as expensive. I'm going to write down two equations. E equals 2C, C equals 2E. One of these is definitely right. One of them captures what's highlighted. Twice as much cheap as expensive. One vote for the second one. A couple more votes for the second one. Yeah, it is the second one because it's saying that the amount of cheap candy is double the amount of expensive candy. So it's the second one. But it's really easy to accidentally write the first one. And this happens a lot when we're translating word problems into symbols. Sometimes the way that the English language works doesn't necessarily translate symbol for symbol into equations. So you just got to really take your time. And if you really are stumped and you're not sure which one it is, don't guess. Just make up numbers. For example, if you have 5 pounds of the expensive stuff and you have twice as much cheap as expensive, then how many pounds would we have here? C should equal 10, right? That would say twice as much of the cheap stuff as the expensive stuff. So I know that the equation had better satisfy those numbers, or said the other way, the numbers had better satisfy the equation. If you plug in E equals 5 into this first equation and C equals 10, we get 5 equals 2 times 10, which isn't true. It's not that equation. But 10 equals 2 times 5. That's right. That's the relationship. So C equals 2E is good. Get rid of that. Circle that. And that C equals 2E is right down there. And now the system of equations is set up. And in fact, I'm not going to spend our time solving it. You can solve the system later. But the heart of this new lesson is just setting things up. So I'll tell you the answers are down here if you want to try checking it later on. 2.6 pounds of the cheaper and 1.3 of the expensive. But we're moving on right now. Any questions on that? Okay, number 2. Amount of money that's deposited in a savings account is called the principal. The money a person earns from the bank is called interest or interest income. And there's a simple relationship that tells you how to figure out your interest. What you do, if you have money invested for 1 year, this is very specific to having money in there for 1 year. To figure out the interest, you take the principal, the amount of money you have in the bank, and multiply it by the interest rate as a decimal. So as a quick example, if you have like $500 in the bank and you earn 8% interest for 1 year, what would I do to figure out how much interest I have coming in? 500 times 0.08, whatever we get there, is that 50, 40? So $40 would be the interest at the end of a year. So we should buy that the interest is just the principal times the interest rate. Again, just because it's 1 year. Okay, so let's see if we can apply that to our systems example here. Jerry invested a total of $2,000 in 2 different banks. The first bank pays 4% interest and the second bank pays 9% interest. His yearly income from the 9% investment is 37 more than his yearly income from the 4% investment. How much did he invest at each rate? Okay, let's start with our table. Again, I will tell you what the variables should be. You just have to read it. How much did he invest at each rate? Those are your variables. So we'll let L be the amount invested at the lower rate, and H the amount invested at the higher rate. And again, units are there, dollars. Okay, let's start filling in our table. The interest rate, what's the low interest rate? As a number is 4%, right? That's the lowest interest rate, but you're not going to put a 4 in the table. You're going to 0.04. Every one of our percentages automatically gets changed into its decimal form. The high interest rate is 0.09. Again, the total 13% is meaningless. There's no 13% investment in this problem, so we'll leave it blank. This first column, oftentimes, is just the variables that you defined. So the amount of money invested at the low interest rate we called L, and the other one was H. And in this case, we do have a total invested. How much? 2,000. That's in the problem. And then the amount of interest income. Well, let's see. This is what we called I. This is what we called R. And this is what we call P for principal. And our new equation is that I is equal to P times R. So to get the last column, what do we do with the first two columns? We multiply them, which is that same pattern that I pointed out in the previous table. So we're just going to multiply here, 0.04 times L, 0.09 times H. And we don't know how much interest we have altogether. There's a 37 in the problem, but that's not the total amount of interest. So we have to leave that last spot blank. Okay, so we're going to get two equations. One of them is from this first column. L plus H equals 2,000. That's just saying we invested 2,000 altogether. Is that all right? The other equation is a lot tougher for folks. It comes from this sentence here. And we're just going to translate this sentence word for word into symbols. Just got to go slow. The income from the 9% investment. That is one of the things in our table. Which one of these is the income or the interest from the 9%? It's the 0.09H. That's it right there. So I'll highlight. The income from the 9% investment is that guy. That's how much interest you get from just that investment. So we're translating now into an equation. 0.09H is what symbol? Equals 37 more than 37 plus. See how we're just going piece by piece. And then finally, the income from the 4% investment. It's in the table. What is it? It's this 0.04 L. 0.04 L. That's the equation. It's about as hard as it gets. But if you take it in bite-sized pieces, I think it becomes more manageable. Okay. So again, we're not going to solve the systems. I think I included the answer. Maybe the answer is on the next page. I'm not sure. But just setting it up is what I was interested in for right now. We see the two equations on the next page. L plus H is the 2,000, and then this one we just wrote. For what it's worth, if you're not a fan of the decimals in that equation, you could multiply both sides of that equation by what number to get rid of the decimals? If you multiply everything by 100, all those decimals will go away. You don't have to do that, but you could. Okay. All right, so I think that is it. And there's a process that you can read through later on if you want to, but it's kind of generically written out, but this is always the idea with these problems. So check that out later. Now, right now you are moving on to the activities. So go ahead and start with number 1. I've provided you blank tables where I think they will be helpful. First thing you'll need to do actually is fill in the row headings and the column headings in the table before you start defining your variables.